Hello, everybody. My name is Herman Langner, and I'm a staff engineer at Zappi, currently based in Cape Town, South Africa. I've been an engineer for about 13 years now, and today I'm going to be talking about my experience in being in the driving seat for adopting Elixir during a high-stakes project where nobody had any Elixir experience. Going to be covering the approaches we took to make sure that we minimize the risk, as well as how to become productive as possible. A lot of these might not be applicable to a lot of your projects, but there could be some elements that you want to take away from it. So the first thing is, I can't really talk about high stakes without any context. So what does Zappi do? Zappi is a market research company that provides automated consumer insights. What that means is, if a client approaches us with a new logo or a flavor or brand or something, we provide them consumer insights that will tell them how successful it will be when they roll it out. So we realized that we were sitting on a meta-analysis goldmine. What's meta-analysis? It's comparing results across multiple studies to identify trends with other parameters and possibly gauging new insights. If we could somehow enable easy access to perform meta-analysis and also customize our data structures so that the meta-analysis could be performed optimally, we were feeling pretty confident that not only would we achieve functionality that would make us industry leaders, we'd be able to innovate incredibly rapidly. And in order to do that, we went through a round of investment to deliver our vision by 2027. And while that sounds like 4 years is quite a long time, unfortunately, making the data platform usable is the first and foundational piece of anything we would want to do to achieve our vision. So we would have to deliver something functional by the end of 2023 so that everything else can prototype and build and become cohesive by 2027. So the first problem we had to solve was, how do we represent all of our data so that we can access it easily? And through trial and error, we discovered Lakehouse was not only incredibly performant, it was fantastic at being efficient in storage and handling multiple forms of context that could represent almost all data that we could imagine. Because it's a ClickOLAP database, we paired it with Postgres so that would act more as an orchestrator and a metadata component. Then the next part would be, how do we get ourselves to mold the meta-analysis for optimal querying? So when you're trying to be dynamic, the first thing you really want to do is make sure you have no malformed or inconsistent data. As soon as you do that, you get really weird inconsistencies later down the pipeline. So we make sure that we eliminate any inconsistencies early, and then from there, we store the comprehensive storage in the Lakehouse format I just spoke about, and from there, using database configurations, you could define what you'd want to group together and format for meta-analysis. Those results would get stored, and you'd also, through a database configuration, be able to pull and merge all of those in any way you wanted. But if you just sort of blink quickly, you can see it's a classic Lakehouse architecture, which was also sort of validating. While we would have loved to just grab it off the shelf tool, the majority of them were very much focused on the BI space, where instant responses and flexibility isn't as important, where this was going to be a core application. We needed very, very fast response times and a lot of other things that they couldn't provide. So from that, we had quite a promising architecture, but we just went through all of our runway. We're pretty confident that this was going to be the solution, but at this point, our entire vision was in jeopardy because everything moved up by quite a bit. So because we felt confident that this is the solution, we did some roadmap gymnastics and expectation management and got ourselves 1 quarter, which is 12 weeks. It's not a lot to deliver a end-to-end tangible feature for a client, all of the data, multiple sources, and making sure it works, and learning a new language. However, if we succeeded, we'd be able to kick off the new app so they can prototype and start working with what we've got, and we can in tandem work with it. But if we didn't succeed, even if it was the right direction, we would have to can the project because we can't invest anymore in this, which would be over a year's wasted effort, but we would have to try and figure out how to salvage what we can for the roadmap. So with this, pressure was real. Was there anything we can do to improve our chances? Well, the problem space was complicated. We're bringing in a new language, and we just generally, there's components that we haven't proved yet. So when you've got a lot of unknowns and things that could change around you, it's always worth, and I would say this for any kind of important project, to just take a few days or a week and really try to go through a process of preparation and pre-mortem. This is not the same as planning. Where planning, you kind of figure out what you want to do and scope it out, where this is more around making as many decisions as early as possible so that when you get to execution, you spend as little time being blocked by roadmaps and confused around what you should do. So it's about having a strategy of, as soon as you get started, you go as fast as possible. And the pre-mortem, one of my favorite things to do, I see it as being pessimistically optimistic. You want to prepare for the worst, but hope for the best. And that pairs quite well with the preparation because it will supplement and enable you to make more decisions from that. But for preparation, let's begin. We need to talk about languages. So Zappi is primarily a Ruby house. The one thing though with Lakehouses is that Ruby's data ecosystem isn't very rich, and on top of that, we plan to scale aggressively, and since then we have. So we knew that we needed to start with something that was highly concurrent. Even though this does bring in the extra risk factor around nobody knows how this language works or the quirks, but with Ruby we knew we'd be sinking an equivalent time into trying to make it have the equivalent scale. So while I really love functional programming and distributed systems, it's not just about, do I want to write this project in that language? It's got to be the foundation for at least the next 5 years. So let's look a little bit more around, you can't really say whether a language is going to be successful or suit what you're trying to do, but you can look for some signals. So the first one is, I can't really comment on whether Elixir would be hard to pick up or not, but there's a lot of new concepts. You're doing a paradigm shift, you're learning functional programming. From Ruby, you haven't done errors as values or a whole bunch of other things, which I just blanked out on. But for me, the most important thing was, in trying to look into how Elixir works, was how the community engaged in trade-offs and decisions and where to go. I still kind of firmly believe that it's truly impressive how Elixir has managed to provide so much functionality out of the box without having an abstraction you don't own dictate how to write your features. And I think there's so many elements of what makes Elixir great that kind of stems from both how the community engages with things and that philosophy. And the other thing was first-class concurrency. Well, I just said it's one of the reasons why we're looking for another language, so I can't not mention that. So with that, we kind of felt like, well, this is about as good as we're going to get, so let's choose Elixir. Which kind of brought to, that was the one decision you need to make to really pessimistically look at where things can go wrong. And this one, I don't know if there's a different term for it, but I call it the funnel of ambiguity. What this is if your project is large enough in scope in a greenfield situation, or there's novel enough problems you're trying to solve, you're going to be surrounded with almost limitless options, known unknowns, unknown unknowns, and trade-offs which you are never sure whether that will actually be correct for what you're trying to do. And the big challenge with this is you only know whether this succeeds by doing it. Which, in those projects, it's inevitable that you're going to hit a dead end somewhere, which, while being inevitable, kind of sucks. It does really help you zone in on what can you do. So if you know this is going to happen, you know that from going from a dead end to another possible solution, there's a period of time in which you switch over, which will be your cost of change. And each attempt might not be constant. You can't necessarily control it, but you might plan to do them first or later, depending on how much impact it could have overall. But if you really zone in on cost of change, you can almost intuitively say there's no real maths behind this, but anecdotal experience is the longer it takes you to change something, the lower your chance of success. But if you flip this around, you can say that if I can reduce how much the cost of change is, I can at least, even if it's marginal, increase my chance of success. So, looking at everything we've got, what parts can we really influence? Well, Elixir is already an abstraction over the beam, so if we can lean into that abstraction, we can kick the can further down the road around learning the inner workings of the beam, and while there's already many paradigms to adopt, we can really focus on the things we need to be successful. And if we are successful, we're going to have a lot more time to actually learn the lower workings of the beam and Elixir. And yeah, the focus is always important, especially when you're trying to build momentum and move as fast as possible. So how could we do this? Well, for our project specifically, we needed these components, and as luck would have it, almost everything was available from installing a package. And what this meant for us was, after we've set up the application, just kind of blindly put things together, we don't have to worry about the beam. And as we learn Elixir, even throughout this process, even during the specific deadline, we did start adapting to beam practices and stuff, but to get started from day one, you know how to do an enum. It's slightly weird, piping school, you're not effectively using streams or enums together. Doesn't really matter, but you're moving forward, and our primary goal was to deliver value and have it built on top of Elixir so that when we do become proficient in the language, we can rapidly scale. And there's one more thing. If nobody's done anything beyond a Hello World app, so there's no chance that the first iterations of this project is going to be anything we wanted to write home about. So rather than just accepting a fate, we go, well, if there's an opportunity to reduce the cost of change, if it's going to be horrible anyway, why don't we make it incredibly easy to both refactor and learn? That way, even if the things aren't perfect, we can at least constantly adapt to what we need and revisit as we're going along, because low cost of change means like not just from deadlines or dead ends. You'd still be able to quickly change things almost as a drive-by. So the first easy one was just have a strict CI/CD. If you don't really know how Elixir works, how things start together, how you should structure your code, and obvious foot guns, all of those kind of come for free. And while initially it might be a bit slower than not having it at all, your rate of learning goes up quite a lot. And the additional benefit to it is that at the end of the day, adding these things later always sucks. Next thing was to avoid abstractions. If you're doing it wrong already, to create an abstraction is always easier from duplicated code than to dissect a bad abstraction. We know it's going to be a bad abstraction, so let's not waste any headspace in trying to be fancy and dry up our code. Let's focus on delivery and revisit when we understand the problem and the language better. I'm going to skip over tests for intent and behavior, but not too much. With tight deadlines, you always end up at a point where you're going to take a shortcut. And that's fine, like you know it's going to happen. And again, now we're going to see what we can do about it, where in this case, if you're already taking a shortcut, you're highly unlikely to document it, let people know why you did this, or write a test for it. You're going to try and skip the test. However, this always, within the short term, bites you because you can't tell the difference between a shortcut and an unintended bug, and there's always a slowdown trying to figure out retroactively what it was. And so almost a gentleman's agreement within the team. Just don't worry about writing the perfect test suite, but make sure that when you do a shortcut, it's well documented, and this has saved us many days. And almost as Phoenix contexts are intended, we use them as domains, and out of everything we want to be strict on, we only want to be strict around crossing the domain boundary, because in the absolute worst case scenario, we know that the domain boundary is the only thing that's ruined, not all the other domains we're working with. So at this point, there were a few other examples, but they were all in the same nature. Some of them were more Zappi specific, not as much Elixir specific, but just at some point, all we had to do was give it a shot. So I wouldn't be here if it wasn't a success. So I'm rather going to skip to a little bit of reflection on this, where while I was preparing for this talk, I thought back on quite a bit of how did it actually go. And what I found very interesting was that as this project really started taking off and things ended up going really well, I never felt less productive, which is kind of strange, because my general experience has been that as you deal with more edge cases, you're building more features, you're trying to tie things together, and you're just dealing with really hard problems at the tail end of a project, you tend to slow the curve. And at this point, it was very anecdotal, but it felt like I missed something. So out of pure luck, 2 weeks ago, one of my colleagues, for completely unrelated reasons, pulled together deployment data. And while deployment data, unfortunately, is kind of vanity metrics and depends on how you develop, we do trunk-based development. But there's some interesting things to see here. In the span of 13 months, our team of 5 deployed 2,000 times to production. And this is almost purely pull request, merge, deploy. And what's really, that's, trunk-based development, your deploy count is high, but what's very interesting is how consistent it is. Per developer, we essentially end up with 1 deploy a day, and across a month, as an average, you had 150 deployments. But the main thing that was very interesting was the min-max deviation from the average. The lowest point of productivity was 120 compared to 150, and the highest one was about 170. So you kind of end up like, this is kind of weird, because I know for a fact that we spent a lot more time in meetings. We really struggled with some obscure bad data issues and just product problems. And the only thing I could really come up to was that either we've just spent a lot of time just renaming strings and feeling good about ourselves, or somebody brought in some obscure dependabot tool to just bump up his personal metrics, which neither of those happened. So you go, well, what's really going on here? And I've got a few suspicions, which I unfortunately can't get into, but I think what really happened is as you learn how to use Elixir better and learn the beam, and you become more efficient at being expressive, you solve problems simpler. So your code base is contradictory, like almost simplifying the whole time. So your productivity is actually going up, but the complexity of the problem is also going up, and they're balancing each other out. So the part that kind of validated to me is basically the last slide, which is where we're at now. So I forgot to include that at this point in time, we've loaded over 70,000 studies from Zappi, which is all of our modern studies and multiple data sources for each one. It's really fast. So we haven't really, this is kind of indicative that we've not really wasted our time. In one of the more recent things we did, I think about 2 weeks ago, we can do 120 aggregations in parallel across 3 million rows, run stats, test like significance and percentiles, and all of those results comes back in 7 seconds. On the old platform, the exact same export, we corrected this importance, so we did this side by side. This was measured in days. One of the biggest drawbacks we had was our data science team can run and publish models in an hour now, where in the past that took 6 months to even get value out of them. So even they're feeling very productive. The same thing happened with our research team. Their work process has really evolved and just gotten better, and a bunch of things you've probably read here, but the main thing for me has been teams have been starting to use our platform for things unrelated to research because it's just been useful. And the main thing for me is I wish we could take credit about efficient planning and all of that, but I genuinely think it's been how much productivity, learning, and getting good at Elixir enables you, and we probably wouldn't have delivered even half of this if we didn't manage to become more productive on Elixir. So my closing note is, if you've been looking for a sign to adopt Elixir, I think this is it, or it's a pretty damn good excuse. Thank you. Yeah,